Now, here's another example. Again, we're given triangle ABF, and we're told that one angle is 30, one side is 2, and one side is 5. So again, we're given two sides and one angle. So here, we're following the same steps. We write out the law of sines, then we plug in the values that we know, and we're left with that 4 equals b over sine b equals 5 over sine f. Well, if we look at 4 equals 5 over sine f, and we multiply both sides by sine f, we get that 4 sine f equals 5, and then we divide both sides by 4. So we get that sine f equals 5/4. However, it's important to note that we know that our sine function, we know that sine only ranges between 1 and -1. So in fact, there are no values of f. There are no values of f that get mapped to 5/4 by sine. So actually, there is no solution to this problem. And you can see this by, again, looking at a picture. So here we have the angles. So here we have our potential triangle ABF. And so we have our angle 30 and our side 5 and 2. However, the side 2 is never going to actually reach the ray coming out of angle A that would make it a 30-degree angle. So there are no solutions to this problem. Now, there are some other cases that we can consider. If we're given a problem where the angle is 30 and the sides are 5 and 6, there's only one solution to the problem. You see that the side 6 is long enough that it's only going to intersect the ray coming out of point A at one point. Again, if the side has length 3 and hits the ray coming out of A at a perpendicular angle or a 90-degree angle, it's again only going to give one solution. So here's another example. This time, again, we're given one angle and two sides. So we have a triangle ABF. We know that angle A is 25, side B is 11, side C is 17. So, same thing as before, we write down the law of sines, and then we fill in the bits of info given in the problem. So now, splitting up each of our little equations, we have that A over sine 25 equals 11 over sine B. However, there are two unknowns in this equation, so we can't solve it. Similarly, we have A over sine 25 equals 17 over sine C. Again, still two unknowns. And then we have 11 over sine B equals 17 over sine C. So again, two unknowns and we can't solve it. So given the law of sines, there's actually no way that we can solve this problem. Instead, we're going to look to the law of cosines. So you can see this is why it's useful to also have a law of cosines. So we know that the law of cosines tells us that a squared equals b squared plus c squared minus 2bc cosine a. And I chose this version of the law of cosines, so the one starting with a squared, because we were given the angle A and the sides B and C. So you can see that we have all of the values on the right-hand side of this equation. So plugging in, B equals 11, C equals 17, and A equals 25, we get that a squared equals 71.06, which gives us that A equals 0.43. So now, given that A equals 0.43, and going back to the equations that we had with the law of sines, we can now plug in our value of little a. Skipping some steps there, you can do it on your own, but you can see that we can now solve for both angle B and angle C, since we only had one unknown in each of those equations.